I'm Jeff Hughes. I work at the Tulsa Maintenance Base facility. I work in the avionics component shop. Today I'd like to take a few minutes of your time to go through the PSEU, Proximity Switch Electronics Unit, that troubleshoots the sensor wiring faults on the aircraft. The Proximity Switch Electronics Unit has a built-in automatic system test and a monitor test for looking at each sensor individually. The first thing we will look at is the automatic system test, which will automatically test each individual sensor on the aircraft. First, we will place the power switch to on. The mode switch will be in auto. We will start the test by pressing the red button. At this time, you will see the fault code display CCC, meaning the test is in process. This test will take approximately 2 minutes. Once the test is completed and no failures were detected, the fault code will display AAA and a pass light. If a sensor or sensor wiring fault was detected in the automatic system test, the test again would have started by a CCC. If a failure had been detected, for example, you would have had a fault code failure 110, and looking up in the left-hand corner under the doors section, you see that 110 fault code represents a prox card failure. This does not mean, however, at this time that the PSEU is at fault. You should again press the red button. It will give you a 180 logic card failure. Again, the PSEU is not at fault. By referencing to the maintenance manual 32-60-00, page 101, the note says, when the automatic system test isolates a sensor or sensor wiring fault, it will also display the corresponding prox card and logic card faults prior to displaying the sensor wiring fault. Again, by pressing the red button for continuation of test, you will see that we have a 257 failure. This failure is a forward cargo sensor wiring failure. At this time, all the fault codes that have been seen should be written down and recorded for further reference. Again, you should push the red button for continuation of test, and you will see again the CCC displayed in the fault code window. Since there was a wiring fault detected, you will see AAA and a fail light displayed in the fault code window. You then can go to the monitor mode by changing the switch up to monitor. This will allow you to look at each individual sensor and the sensor wiring on the aircraft. The automatic system test placard on the front of the PSU has a corresponding fault code number that was previously recorded of the sensor wiring fault. The channel to monitor is determined by the sensor wiring fault printed to the right of the fault codes. The channel select on the front of the PSE should be selected to the corresponding sensor wiring that is at fault. For an example, we had the 257 failure. Again, we go to the monitor, which we were in, and with the 257 failure that we had, showing that it was the forward cargo sensor wiring fault, we then go to the sensor status monitor placard, and since we had a door failure, you go down the sensor column that says forward cargo, and we see that the channel select for forward cargo is channel select 03. Now that we have decided that the channel select should be 03, down at the bottom right you will see channel select. This should be turned to 03. That is the channel select sensor that we want to monitor. To know that this is correct, you can look at your fault code window again, and it will tell you that you are looking at channel 03. And it will indicate, if you have a failure, a fail. If there is no open or a short at the sensor or the sensor wiring, you will detect a pass at channel 03, showing that there is no open or short detected. Again, if it was detected that we had an open or a short and the fail light was displayed, if all the wiring on the aircraft pertaining to that sensor has been checked out and it checks out good, then the sensor should be replaced. Once the sensor has been replaced or the wiring has been repaired, you then can go back to your automatic test, and you should be able to run the automatic system test without any failures. We can now go and see if the sensor actuates and deactuates properly. Once it is determined that the sensor wiring is all good, the target far, target close positions of the sensor can be monitored. Operating either the aircraft's corresponding doors, slats, etc., whichever is proper for the failing sensor, or using a go, no-go target troubleshooting tool, the target far and target close actuations can be monitored by watching the target display on the front panel of the PSEU for either an F, which represents target far, or a C, target close. This will tell the operator that the PSU that the sensor is actuating and deactuating. LDEC Company has a go, no-go troubleshooting target tool to check the proximity of each sensor for its proper actuation and deactuation. With this person being out on the aircraft with a target tool in one position with the person watching the target display and the tool being in one direction of proximity, you will see that there is an F displayed, which indicates that the sensor is detecting a target far condition. By flipping the proximity target tool over, you see that the target fault code display changes to a C, showing that the sensor is detecting the correct proximity and changes to the target close condition. If the proximity of the sensor is not correct, it will not actuate or deactuate at the correct proximity, and the sensor should be replaced. This can be detected when the PSEU target display will not change target far or target close conditions, but the target for the sensor on the aircraft, the door, the slat, etc., has the proper gap. In closing, two items of great importance should always be kept in mind when troubleshooting this system. If the PSEU displays only a sensor wiring fault before displaying a prox card and logic card failure, it is most likely that the sensor wiring is not at fault. Also, be sure that the proper rigging of the sensor on the aircraft is correct. If the gap between the target and the sensor is improper, the sensor will not actuate or deactuate properly. This gives false indications in the cockpit. Proper rigging of the target and the sensor is a must in how well and how reliable this system will operate.